exponential equations. So today I'm going to introduce a new kind of equations called exponential equations. So what an exponential equation is? It's an equation in which the unknown occurs as part of the index or exponent. Here is an example of a very simple exponential equation. 2 to the power of x equals 8. Okay, so let me write it down for you. So 2 to the power of x, 2 to the power of x equals 8. Once you have such an equation, your unknown is x, and as you see, it is the part of the exponent. And what you need is to find the value of x so that it satisfies this equation. And one can easily find such value. X equals 3. As you can check yourself, 2 to the power of 3 equals 8. So this would be the solution to the equation. Another example is outlined here. 30 times 3 to the power of x plus 1 equals 271. This is also a very simple one and can be solved, and you can try it yourself. I will not solve it at the moment. Now, some of the exponential equations are very easy to solve, as you have just seen yourself, but some others are quite hard. For example, imagine this one. 2 to the power of x equals 10. If you have to find the value of x that satisfies this equation, then you are in trouble, because you know that if you use 3 for x, you get 8. 2 to the power of 3 is 8. If you use 4, you get 2 to the power of 4, which is 16. So 16 is greater than 10, and 8 is less than 10. So the value of x must be somewhere between 3 and 4, and we are clueless about what it actually is. We do not know at the moment. There is a method that can be used to solve such equations as this one, and it's called the method of logarithms, and we will learn this method, but you have to wait until the next chapter for this. So let us ignore such equations that lead to the use of logarithms. We will ignore them at the moment and concentrate only on simple elementary cases in which we can solve them. Some of the exponential equations can be solved algebraically using the following theorem. And the theorem states a very easy to understand idea that says that if a to the power of x equals a to the power of k, then x must be equal to k. So the basic idea behind this is the following. If we are able to simplify both left-hand side and the right-hand side of an exponential equation so that they are in the form of power with the same base, then the exponent on the left-hand side and the exponent on the right-hand side of the equation have to be the same. If I wanted to use this method for the equation 2 to the power of x equals 8, here it would be 2 to the power of x equals, and then I would try to simplify 8 or rewrite 8, transform it to this form that it has the same base, and it would be a power. So 8 is 2 to the power of 3. So my equation in a transformed form is here. 2 to the power of x equals 2 to the power of 3, and using this simple idea here, we can see that it follows that x equals 3. Since the bases are the same, then also exponents have to be the same. Okay, so if the base numbers are the same, we can equate exponents. So what we do here, we equate exponents. Some examples of this method will follow shortly.